Alright? Last thing we're going to look at are special products. These are special cases where with multiplying polynomials, it's important for you to remember. And one of the things that we want to look at here is why these things are true. Binomial conjugates, which is also I will refer to as the difference of squares case, okay, is this situation that if I have an a plus b and an a minus b, a could be anything and b could be anything. If I get an a plus b and a minus b and I'm multiplying those, that will result in a squared minus b squared. Okay, let's take a look at why. Quickly here, if I FOIL this, I get a squared minus ab, and a times b, which is plus ab, and b times negative b is negative b squared. And what you'll see here is always these two middle terms cancel out, leaving me with a squared minus b squared. So that's where that comes from. The middle terms cancel out. Now, the next one is squaring a binomial, and we'll take a look at this one right here real quick. What it means to square something is to multiply it by itself. So let's look at why this ends up being what it is. So if you have a plus b quantity squared, if we FOIL this, we get a squared plus ab plus ab plus b squared. Okay, and you'll notice these two terms here are always the same. So we end up with a squared plus 2ab's plus b squared. These are special products that we need to remember. This part is important. And down here, this shouldn't be a plus minus here. This should just be a plus. Well, I'm sorry. It can be a plus minus. We need to put a plus minus here. You'll notice the common error by students is when you have this a plus b quantity squared, you do a squared plus b squared. It is not that. It is what we just discussed above here. Okay? So you need to take a look at that and make sure you understand it. Alright, so if we look at the first example here, this is binomial conjugates, or it's the difference of squares. Notice this is a and b and a and b. Okay? Plus minus. So this one results in 9x squared. Well, we'll say this is 3x quantity squared, a squared minus b squared, which results in 9x squared minus 16. Okay? The next one here, this is a binomial square. So according to our binomial squares up here, we end up with y squared plus 2 times a, which is y, times b, which is 3, plus 3 squared, or y squared plus 6y plus 9. Okay? That's your final answer there. And then the last one, again, it's a squared. Now, these are shortcuts. You could, if you wanted to, just write this out as 3x minus 2 and 3x minus 2 and use the FOIL or distributive property if you wanted to. But in this case here, we're going to go ahead and use our special product here. So we're going to end up with 3x quantity squared, because that's what a is, minus 2 times a times b, b in this case is 2, plus b squared. Okay, which ends up with 9x squared, let's see here, minus 12x plus 4. Okay? Again, these are shortcuts. You could just FOIL them and you would end up, or distributive property, use distributive method, and you'd end up in the same place.